Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2018, Paper 1, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA past paper walkthrough. Today we're going to be having a look at the November 2018 paper 1 and we're looking at the higher tier today. Question 1. Simplify 5 to the power 4 all raised to the power 2. Circle your answer. Okay, so this is what we call an index of an index, where we've got something inside the bracket which already has an index, and then you're raising that thing to another power. So what we have to do basically here is multiply those indices together. So we're going to be multiplying 4 and 2 together, and that is going to give us our new combined power of 5 to the power of 4 times 2, which is 8. So the answer is that one there, 5 to the power of 8. Question 2. Circle the volume in cubic centimeters of a cylinder with radius 5 centimeters and height of 8 centimeters. Okay, now a cylinder is a circular prism, and a prism, the volume of a prism is its cross-sectional area times its length or its height. So the cross-sectional area of a cylinder is a circle, so that part is going to be pi r squared, and then the distance between them then is going to be the h, giving you a volume of pi r squared h. Okay, now subbing in what we know that the radius is 5 and the height is 8. So that's going to be pi times 5 squared times 8. 5 squared is 25, 8 25s are 200. So that comes out to be 200 pi, which means our answer is that one there. Okay, question 3. Simplify 16a squared divided by a plus 3a times 2. Okay, quite a lot going on in this expression. If we're going to simplify it, we're going to use BIDMAS, aren't we? BIDMAS, brackets, indices, division, multiplication, addition, subtraction. So we can see division, multiplication becomes before addition, subtraction. So they're the bits we're going to do first. So I've got a division here, look, 16a squared divided by a, and I've also got a multiplication here. Now, although D becomes before M in BIDMAS, they actually kind of have the same weighting. So we do them together. I just work through from left to right if there's more than one. So 16a squared divided by a. Well, a squared divided by a is just a. So that a cancels into that square power, leaving you with 16a. And then I've got a plus sign, and I've got 3a times 2. 3 times 2 is 6. So that's going to give me 6a. And 16a plus 6a, we can now add those together, and that's going to give me 22a, which is this one here, isn't it? Question 4, circle the value of cos 30 degrees. So for your GCSE, you're going to have to remember the exact values for certain key trigonometric ratios. The ones you need to remember are the angles 0, 30, 45, 60, and 90 degrees, and you'll need to remember the sine, cosine, and tangents of all of those. Now, I'll stick them all up in the table for you to have a quick look at now, but you do need to try and remember this table. There are some shortcuts. For instance, if you have a look at the sine row, you'll notice that if you turn it around the other way, you're going to get the cosine values, and you can actually work out the tan values by dividing the sine and the cosine ones together. There's also another way to remember it using your hands. I might make a video on that at some point and post it. But from the table, you can see that cos 30 is this one here, root 3 over 2. It's one of those ones that you're going to have to learn one way or the other. Otherwise, you're not going to be able to answer these sort of questions in paper 1. Okay, question 5. Work out 8.5 divided by 2 2/3. Now, very simple if I had my calculator, but we don't, so we're going to have to do this the long way. Okay, so first off, let's rewrite these as improper fractions or top-heavy fractions. 8 times 2 is 16 plus 1 is 17, so 8.5 becomes 17 over 2. And that's divided by, well, 2 times 3, that gives me 6, plus the 2 makes 8, so that's 8/3. So I've got 17 over 2 divided by 8 over 3. Now, you should know that dividing by a fraction is the same as flipping it over and multiplying. So I can rewrite that as 17 over 2 times 3/8. Have we got any common factors top and bottom? Doesn't look like it, so I'm just going to have to multiply this out and see what we get. 17 times 3, 17, 34, 44, 51, isn't it? 51 over 16. Okay, I did already try and cancel it down. Okay, it says give my answer as a mixed number here, so we're going to have to rewrite it as a mixed number. 16 goes into 51 how many times? 16, 32, 48 goes in 3 times, remainder 3. So I'm going to rewrite this as 3 because it goes in 3 times, and remainder 3. So numerator of 3 over 16. So 3 3/16. Question 6. A ship is sailing in a straight line from its home port. The distance time graph shows 4 hours of the journey. And we've got the distance from the port up the side here, and that's in miles. And we've got the time along the bottom, and that apparently is in hours. Okay, and now we're asked to work out the speed of the ship during these 4 hours. Now, you hopefully remember the relationship between distance, speed, and time. If you don't, this handy triangle is quite useful. DST triangle. You notice they're in alphabetical order. DS and then T. And then you can cover up the thing that you want to find and work out the formula used in the other 2 parts. So work out the speed of the ship during these 4 hours. So we want the speed, which is this one here. So we cover up the S, and that tells me what to do with the others. So average speed is distance traveled divided by time taken. Okay, so how much distance is traveled? Well, the distance traveled is, let's just triangulate a little bit so we can see what's going on a bit more clearly. So I'm just going to draw a triangle along here, up here. So then the distance travelled is this distance between here and here then, isn't it? So how far is it from there to there? Well, the top value is here. I've got 5 little squares between 100 and 120. So 20 divided by 5 is 4. So each one of those little squares is going to be 4 then, isn't it? So that top mark there is at 116. And the bottom one down here is 2 little squares up from 40. So if each one of those is 4, that's going to be 48. So then the distance travelled is going to be 116 subtract 48. What's that then? 52, 62, 68, isn't it? That's 68. And the time travelled then is this distance along here. That's a lot easier to work out. That's 4. Okay, so we travelled 68 miles in 4 hours. So if we divide one by the other, we should get the answer in miles per hour then, shouldn't we? So 68 divided by 4. 4's into 40 go 10 times. So 4's into 60 go 15 times plus another 2. That's 17, isn't it? So 68 divided by 4 is 17. Okay, so then that is 17 miles per hour. That's my final answer. Question 7. The sum of the angles in any quadrilateral is 360 degrees. So for example, in a rectangle, 4 times 90 is 360. Zach writes 5 times 90 is 450 degrees. So the sum of the angles in any pentagon must be 450. Is he correct? Tick a box. Well, I'm thinking that he is not correct here. I'm going to tick no. Now, the reason why the angles in a quadrilateral add up to 360 is if you draw a quadrilateral, you can take a quadrilateral and you can divide it into 2 triangles, and each one of those triangles has an the angles add up to 180. So then in a square, which has got 4 sides, is 2 times 180, which is 360 degrees. Okay, now for a pentagon, when you've got 5 sides, 1, 2, 3, 4, 5, you can subdivide up a pentagon into 3 triangles, each one having 180 degrees as a sum of their angles. If you notice that those angles also make the angles at the edges of my pentagon, so I can work out the angles as 3 times 180. 380 is 540. So the angles of a pentagon should add up to 540. Now generally, if you've got an n-sided polygon, then it's going to be n minus 2, 2 less than the number of sides, times 180. And you can see that in the pattern above. In there I've got n is 4, haven't I? When n is 4, then it's 2 times 180. When n is 5, then it's 3 times 180. So if I've got n sides, then I'm going to have n minus 2 times 180 as the sum of the interior angles. Question 8. Kim works at an airport in the UK. She records the number of planes landing between 10 AM and 2 PM each day. The table shows the data for the first 10 days in January. So you can see you've got a table with numbers of the days, 1 to 10, and then a number of planes that landed on each of those 10 days. Okay, so it says 8A, the airport was affected by fog on one of these days. Which day do you think it was, and give a reason for your answer? Okay, so having a scan through these numbers, they're all about 150, aren't they? So 148 is a little bit below, 151 is a little bit above, but pretty much bouncing around 150, apart from this day here, where it drops significantly lower down to 102. So I'm thinking that must be the day that it was foggy, because when it's foggy it's harder to land planes, I suppose. So I'm going to say that it's 8. Oops, not like that. I'm going to say that it's day 8, and the reason I'm going to give it is that there are fewer planes. Now it's only a 1 marker, so I'm not going to write an essay for it. I think that's good enough reason. I've given the date and I've given a reason why I think it's that. So good, let's move on. 8B. Kim uses the data to predict how many planes will land at the airport in a year. In her method, she uses an estimate of 150 planes in each 4-hour period throughout the day. Assume that the same number of planes each day. Work out her prediction. So, how many 4-hour periods are there in a day? In 24 hours, so if I divide 24 by 4, 4's into 24 go how many times? It goes 6 times. So there's going to be 6 lots of a 4-hour period, aren't there, in each day? Okay, now there are 365 days in a year. So 365 days times by 6 4-hour periods and 150 planes in each 4-hour period. Got to work that out. So 150 times 6. Let's do that bit first then. So let's double it. It gives me 300 and then times it by 3. That's going to be 900. So I'm going to have 365 times 900. So 365 times 900. So I can just do 365 times 9 and add a couple of zeros on the end. Then so 365 times 10 would be 3,650. So if I take 365 away from that, 3,650 take away 365. So that's 3,285 with another couple of zeros on the end. So I make that 328,500. So 328500 is my answer. Part C says, in fact, fewer planes land in winter than in summer, and fewer planes land at night than during the day. What does this tell you about Kim's prediction? Is it too high, too low, or could it be too low or too high? Let's have a quick look. Did it tell me what time of the day she went? She went between 10 AM and 2 PM in January. Okay, so now because she went during the daytime rather than the nighttime, that means there are kind of more planes there during the day than there were during the night. So that would kind of tend to be that 150 per 4-hour block might be an overestimate. But then it's in January, which is in the winter, and so in the summer there are going to be lots more planes. So I think I'm gonna say that it could be either then, couldn't it? Her prediction could be too low or it could be too high, because we don't know. What's the reason? So her data was taken in winter, indicating it might be too low, but she also sampled during the daytime, which might be too high. Question 9. We're told that the root of 6 squared plus 8 squared is equal to the cube root of 125 times a cubed, and we want to work out the value of a. Ooh, okay. I'm going to kind of come at this from both directions, I think. So I've got 6 squared plus the 8 squared. I'm going to work that bit out. 6 squared is 36, and 8 squared is 64. So I want to find the square root of that, and that's equal to the cube root of 125 times a cube. Now I can actually break that out into two separate cube roots. I can say that's the cube root of 125 times the cube root of a cubed. Okay, so we're making some progress here. 36 and 64, that adds together to give me 100. So I've got the root of 100. Right, what's the cube root of 125? 5 times 5 times 5 is 125. So the cube root of 125 is 5. And then what's the cube root of a cubed? 8 times a times a is a cubed. So the cube root of a cubed is simply a. Okay, so I've got 5 times a is equal to the root of 100. Now the root of 100 is 10. And cross multiplying that 5 to the other side, I'm going to get 10 over 5 is equal to a. In other words, a is equal to 2. A is 2. Question 10. Work out the percentage increase from 80 to 280. Okay, so with my percentage questions, if you're a regular viewer, you'll know that I use a triangle, a bit like the DST triangle we used earlier, but this time I've got final, original, and multiplier that goes inside it. FOM, stick your thumb on it. And what I do is I cover up the thing that I want to find and use the other values to work out my answer. So what is the final, original, and multiplier here? Now, I want to work out the percentage increase, so I actually want to find the multiplier, that's the unknown. And my percentage increases from 80 to 280. So it was 80, it was originally 80, and it becomes 280. So the final is 280. Okay, so then using the triangle, covering up the thing I want to find the multiplier. The multiplier is equal to the final divided by the original. Multiplier equals final divided by original, which is 280 divided by 80. What's that then? 8's into 280. Well, 80, 160, 240 goes in 3 times, remainder 40. So it's 3 and 40/80ths, which is the same thing as 3.5 or 3.5. Okay, so I've got a multiplier of 3.5. That's quite a big multiplier. So a multiplier of 100% would leave it the same. So my percentage increase well, 3.5 as a percentage is 350%, but I start with 100%. I've now got 350%, so the percentage increase must be 250%. Okay, so my answer is 250%. So just remember, you always start with 100% with these sort of questions. So if it's now 350, it's increased by 250%. Question 11, here are 4 triangles. I've got A, B, C, and D with various angles and sides given. And we're asked to find, well, we're told which 2 triangles are congruent. Circle the 2 letters below. So which of these are congruent? Now we've got 4 different tests for congruency of triangles. They are the side rule, side angle side, which is 2 sides and the included angle. The ASA rule, 2 angles in the included side, and RRHS. Okay, so we've not got a right angle, so it's not that one. We haven't got 3 sides given, it's not that one. I've been given 2 angles and the included side for most of these, so we're going to be using the ASA one, aren't we? Not that one. Okay, to work out which one is congruent. Now, I've written ASA. I didn't write AAS or any other combination. The S needs to be between the 2 A's in order to state that they're congruent. So we can see up in triangle A, I've got an angle of 56 and 25, and I've got the side 8 between them. And I've got the same combination down here at 25, 25, 56, and the 8 between them. So it's going to be A and D that go together. So this one and this one are congruent. Now the other 2, you could still, you could still use ASA if you worked out this other angle, and then you've got 2 angles and the side between them. But you'll notice it's the different pairing, isn't it? So on this one down here, C, I've got 56 and the unknown, and on the other one I've got 25 and the unknown is the 8 side. So whilst you can still work out the angles, you can't show that those 2 are congruent. So it's A and D. A and D. Question 12. Solve x squared minus x minus 12 is equal to 0. So this is a quadratic equation. It's already equal to 0, so we should be able to factorize and solve it that way. It's a non-calculator paper, which leads me to believe that we should be able to solve it by factorizing. Also, they're not asking the answer to be written to 2 decimal places or anything like that. So I'm going to give a crack at factorizing this then. So x times x gives me my x squared. Now the last term is minus 12. So I've got to think of factor pairs of 12 then. So I've got factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. We will need to work out which one of those has got a difference of 1. It's going to be that one there, isn't it? 3 and 4. So it's a negative number, so one is positive and one is negative, and the difference is negative 1. So it's going to be the bigger one, which is going to be the positive. It's going to be the negative number, so the 4 goes there. And the smaller one of the two, it's going to be the negative one. Just double check at this point here that they do actually multiply out as you thought. So x times x is x squared, 3 times x is 3x. X times minus 4 is minus 4, it's going to be minus x in the middle, and 3 times minus 4 gives you minus 12. Okay, so I've got x plus 3 times x minus 4 is equal to 0. Now to solve it, I'm going to make each bracket equal to 0. So x plus 3 is 0, telling me that x is equal to minus 3, or x minus 4 is equal to 0, giving me that x is equal to 4. So my two solutions are x minus 3, x is equal to 4. Question 13. E to f is equal to 2 to 3 and f to g is equal to 5 to 4. Work out e to g. Give your answer in its simplest form. Now, if we could only work out the ratio of e to f to g, then I can just very simply relate e and g together. That's kind of what I want to be able to do, isn't it? I want to link all these various ratios together, so I can then compare e and g. So I've been told e to f is 2 to 3, so I could put a 2 there under the e and a 3 under the f. And I've also been told that f to g is 5 to 4, so if I can put a 5 here, then I can put a 4 there. Okay, so what we want to do is link these two together. So basically, having a look at these two numbers here, can we find a common multiple of 3 and 5? Well, yes we can. It's 15. So if I can make my f term in the middle 15, then I would have been taking this first ratio of 2 to 3 and I'd be scaling it up using a factor of 5. So 2 to 3 goes to 10 to 15, doesn't it? So that makes the e part down here 10. And now 5 to 4, I can scale up to 15 to something by multiplying it through by 3. 5 times 3 is 15. 4 times 3 is going to be 12. Okay? So now I know that e to f to g is in the ratio of 10 to 15 to 12. And therefore, the ratio of e to just g then is going to be equal to 10 to 12. And that simplifies down, doesn't it? 10 to 12 simplifies down to 5 to 6. So my final answer is 5 to 6. Question 14. A and B are two events. Some probabilities are shown on the Venn diagram. And we need to work out the probability of A dash union B. Okay, so A dash means the complement of A, or everything not in A. Union means it could be either in one or the other, and B is just a set B. So that means it can be inside the set B, or it can be outside A. So we're talking about all of this area. Okay, so the only bit then really that isn't included is that bit inside A then, that 0.3. Now just take care of this diagram because there's some bit missing. It says some of the probabilities are shown. It's actually missing a bit, isn't it? Because the complete diagram should add up to 1. So 0.3 plus 0.15 plus 0.35, you'll see only adds up to, what's it add up to? 0.8. So I've got 0.2, which is missing. So there should be a 0.2 floating around outside here somewhere. So the probability of it being neither is 0.2. Okay, so then the probability then of A dash union B, the complement of A union with B, is going to be my 0.15 plus the 0.35 plus the 0.2, or basically everything apart from the 0.3, so it's going to add up to 0.7, isn't it? Okay, so the other way of doing it is just taking 0.3 away from 1, and you'll get the same answer. Either way, it's 0.7. Question 15. In a survey, queuing times at supermarket checkouts were recorded. One morning, samples of 50 customers were taken at supermarkets A, B, C, and D, and the box plots representing the results are shown here. So these are a measurement of queuing times then. Okay, and we've got the 4 different shops, A, B, C, and D, and each of the shop has its own box plot showing the quartiles and the highest and lowest values and the median. Okay, so the question says, on average, which supermarket had the lowest queuing times? Give a reason for your answer. Okay, so average here would be the median. Now the median is the middle line in your box plot. So we're talking about this one here, and this one here, and this one here, and this one here. Okay, and the lowest queuing time average is going to be the one which is lowest down on the scale then. So that is going to be C, isn't it? Because C is at 4 minutes, where D, which is the next one, is at 5, and then B is at 6, and A is well up there. It's long at 10. Okay, so the supermarket that has the lowest queuing time is going to be C. I'm going to say it's supermarket C, and my reason is the median wait time, which was 4 minutes, is the lowest of the 4 supermarkets. Okay, we're not done. There are more questions to answer. So part B says, at which supermarket were the queuing times the most consistent? Okay, so consistency is, they're talking here about dispersion, how widely spread out your values are. Now, box plots actually have 2 different measures of dispersion included. You've got the distance between, or how wide the box is itself, that's your interquartile range, and you've got your whiskers that spread out to the highest and lowest values. So if you subtracted one from the other of those, it would give you the range. So box plots give you the range and the interquartile range. Now, if you're given both, then I would suggest that the interquartile range is going to give you a better estimate because it's less affected by outliers. Okay, so given both of them, I'm going to be looking at just one. I'm going to look at the interquartile range on the basis that that is a better measure of dispersion than range. Okay, so what is the interquartile range of our 4 values? So our interquartile range then for these, okay, so let's have a look at A. Now the lowest value, Q1, is this one here, look, and that's at 8 minutes, and it's Q3, its upper quartile is in there. That gives us an interquartile range of 7, it's 12 take away 7, isn't it? It's got an interquartile range of 4 squares. Okay, now my next one, B, the interquartile range goes from Q1 there 5 up to Q2, which is 7, Q3, sorry, which is 7. So that gives us an interquartile range of 2. Supermarket C has got quite a wide variation here. Goes from 3 all the way up to 8, giving it an interquartile range of 5. And then D goes from 4 up to 7, giving us an interquartile range of 3. So in terms of the interquartile range then, the one with the least amount of variation then is going to be this one here, which is B. So B has the least variation, so it's the most consistent, isn't it? So which supermarket has, were the queuing times the most consistent, it was at supermarket B, and my reason was the interquartile range was smallest, and it was 2, wasn't it? Okay. Now, like I say, you could have used a range here, and I suspect that you'll be given full marks if you did, compared the range of the 4 of them, but interquartile range is a better measure of dispersion, which is why I chose it over range. Question 16. Circle the number that is closest to the value of 29 cubed. Okay, so cubing something is multiplying it by itself 3 times. So I don't really want to work out 29 times 29 times 29. But if I estimate 29 to be close to 30, then 30 cubed I can easily do. 3 cubed, 3 times 3 times 3 is 27. Add on 3 zeros, it's going to be 27,000, isn't it? So 30 cubed is 27,000. So 29 cubed is going to be a little bit less than 27,000, maybe 26, 25,000. But anyway, that one is definitely going to be the closest. Question 17. Work out the exact value of 3/4 to the power of minus 3. Okay, so a negative index. I'm going to do this in 2 parts. I've got the negative index and I've got the 3, and I'm going to do those as 2 separate operations. So first off, dealing with the negative index, that means the reciprocal. So I'm going to just simply switch the numerator and the denominator of my fraction around. So 3/4 to the power of negative 3 is going to be the same thing as 4/3 to the power of 3. And then I'm going to cube both parts of my fraction then. 4 cubed is 4 times 4 times 4, it's 64. You should really know your cubes up to 10, be handy for the exam. And 3 cubed is 27. So my fraction is 64 over 27. So learn your cubes up to 10 times 10 times 10. It'd be very handy for your GCSE. Question 18. Beth and Mia translate documents from Spanish into English. A set of documents that would take Beth 8 days would take Mia 10 days. Beth starts to translate the documents. After 2 days, Beth and Mia both work on translating the documents. How many more days will it take to complete the work? You must show your working. Now, probably the easiest way of dealing with this problem is coming up with a multiple of 8 and 10, a common multiple, and then kind of assigning that as the amount of work that needs to be done. So if I say work to be done, and I let that equal to a multiple of 8 and 10, let's call it 80. So I've got 80 units of work to be done. Okay, so I've got 80 units of work to be done. I've just worked out what 8 times 10 is. So if you think about Beth's output then, she's able to complete the job in 8 days. So if she can put out 80 units in 8 days, then she is putting out 10 units of work per day. Okay, now Mia, on the other hand, would take 10 days to complete this task. In other words, her output is slightly less, isn't it? She's managing 8 units per day. Okay, so then over her 10 days, she'd put out 80 units and complete the work. Okay, so now we know that, it's a bit easier to answer the question then. So it says here that Beth starts to translate the document. So after 2 days, Beth and Mia both work. So for the first 2 days, Beth is working on it on her own, isn't she? So Beth's output is going to be 2 lots of 10 units. So she's going to put out 20 units, isn't she? So what's left remaining is going to be 80 units less those 20 units, which means there's 60 units left to be done, okay, on the remaining days. Okay, so then the next set of days, you've got Beth and Mia working together. Now between them, they are able to produce 10 plus 8, 18 units of work today. So combined output is going to be 10 plus 8, which is 18 units per day. Okay, and now we've got 60 units to do, and we are doing it 18 units per day. So how many days is that going to take us? So it's going to take 18, 36, 54. It's going to take another 3 1/3 days, isn't it? 54, 6 18ths is a third. So it's going to take, so basically what we're doing is we're dividing 60 by 18, aren't we? And we're saying it goes in 3 times, remainder 6. So 6 18ths, 3 6 18ths, which is the same thing as 3 1/3 of a day. So 3 1/3 days. Now, because of how the question is asked, how many more days will it take to complete the work? I think you could get away with just saying that it was 4 days. So slightly more than 3 days, and therefore 4 days. I think 4 days would give you all the marks, but more accurately it's 3 1/3 days. Question 19. In a chess club, there are X boys and Y girls. If 5 more boys and 8 more girls join, there would be half as many boys as girls. Show that Y is equal to 2x plus 2. So we know that X plus 5 is the new number of boys, and we know that that's half as many as the number of girls. So if we doubled it, then it should be equal to the number of girls, which is Y plus 8. So that gives us 2 lots of X plus 5 is equal to Y plus 8. So multiplying out the brackets, 2x plus 10 is equal to Y plus 8. And then subtracting 8 from both sides, I can see that 2x plus 2 is equal to Y, which is what I was asked to find, isn't it? But the other way around. So Y is 2x plus 2. (19b) says, if instead 10 more boys and 1 girl join, there would be the same number of boys and girls. So that means if I take x and I add on 10, that's going to be equal to y plus 1 then, isn't it? Okay, so that's going to give us a second equation. Taking 1 from both sides, I'm going to get y is equal to x plus 9. In other words, y is equal to x plus 9. So that's my second equation. My first equation was this one up here. Y is equal to 2x plus 2. So then if I subtract one from the other, I should eliminate y. Or I can just kind of plug them together where the y's are. So let's do elimination. So equation 1 subtract equation 2. So y is equal to 2x plus 2 is equation 1, and y is equal to x plus 9 is equation 2. So subtracting them, y take away y is 0, 2x take away x is 1, and 2 take away 9 is -7. So that tells me then that x is 7 and y is 9 more than x, so y must be 16. X is 7, y is 16. Question 20. P, Q, R and S are points in a circle. PXR and QXS are straight lines, and we're told that PX is equal to SX. Okay, so we need to prove that QS is not a diameter of the circle. So if this is not a diameter, then it doesn't pass through the origin. And it also means that if I subtend an angle off of it, like this angle up here, then that is not going to be a right angle then, isn't it? So I think that's basically what we need to do. We need to find that angle OPS and show that it's not a right angle. Because if it was a right angle, it would imply that QS was the diameter. So that I'm subtending a triangle, an angle off the diameter, and giving myself a right angle. Okay, so I'm just to make that super clear. If I have got an origin, a diameter passing through the origin, and I draw an angle off of it, that one will always be a right angle. So if I find that OPS, this angle up here, isn't a right angle, then that cannot be the case, and therefore QS is not a diameter. Okay, so that's my plan of action. I'm going to find QPS. Now we can see that QPS is made up of two smaller angles. It's made up of that one there and that one there added together. So this is a isosceles triangle. So if I can find that one, then it must be equal to the other one. Can I find that one? So because the top of that isosceles triangle is 50, then this one is going to be 180 minus 50 divided by 2 then, isn't it? So 180 take away 50 is 130, and 130 divided by 2 is 65 degrees. So that one there is 65 in there, which means this part over here, RPS, must also be 65 degrees. Okay, so we've got half of the green angle. Now we need to find the other half. Now we can know that that half is the same thing as this angle here, 27. So that one is going to be 27 because of it's subtended off the same arc QR. So we're going to write all that down now. So 27 plus 65 is not 90, is it? It's 85, 92. So it isn't a right angle, and therefore it isn't going to be an angle in the semicircle. So I'm going to write all that down then. So I'm going to say that angle XSP, is equal to, we said it was 180 minus 50 over 2, which is 65 degrees. And the reason for that is angles in an isosceles triangle okay, so now I knew that one is XPS, and so I also know that the other angle XPS is equal to that as well, so they're both equal to each other. So XPS is the angle we were actually trying to find, wasn't it? And then QPR, angle QPR, I'm saying is equal to angle QSR, and that is equal to 27. And that is because they are angles subtended from the same chord QR. They are equal. That's the rule. Okay, so angles subtended from the same chord QR are equal. They're equal to 27. So then my angle QPS, so my angle QPS is going to be those two angles added together, then, isn't it? It's going to be angle XPS plus angle QPR. And that is equal to 65 plus 27, which is equal to 92 degrees. So we found that QPS is equal to 92 degrees. And we're saying that's a problem now because it should be 90 degrees if it was angles in the semicircle. So if, what side was it? It was QS. If QS was a diameter, then QPS would be 90 degrees because angles in a semicircle are 90 degrees. and it isn't. It's 92, isn't it? But as angle QPS equals 92, then we can say that QS is not a diameter. Okay. So I've been clear there exactly what angles I've found and also why I don't believe QS is a diameter, and that should be enough to get me all 4 marks. Question 21. Here are the first 4 terms of a quadratic sequence. I've got 11, 26, 45 and 68. Work out an expression for the nth term. Okay, so we've got a quadratic sequence. So you'll notice that the difference between these numbers, 11 and 26, the difference is 15. Between 26 and 45, the difference is 19. And between 45 and 68, the difference is 23. Okay, so you can see that it's not a linear sequence, because if it was, it'd have a common difference, and it hasn't. The difference is increasing, 15, 19, 23. But what it does have is what a common difference of a difference. So the difference between 15 and 19 is 4. The difference between 19 and 23 is 4. So that 4 gives us a big clue to the structure of the nth term of this equation. So this is commonly known as the second difference, the difference of the difference. The second difference is 4, and so that means then my nth term includes, what we do is take the half of that difference. So 4 divided by 2 is 2. 2n squared is going to be one of my terms, 2n squared. Now I don't know what the rest of the quadratic is going to be, but I do know that one of the terms now is going to have 2n squared in it. So if I take my sequence, which is 11, 26, 45, 68, 11, 26, 45, 68, and I compare that with 2n squared. So this is n is 1, n is 2, n is 3, n is 4, isn't it? Okay, so if n is 1, then 2n squared is going to be 1 squared. 1 times 2 is 2. If n is 2, 2n squared is going to be, 2 squared is 4 times 2 is 8. If n is 3, n squared is 9 times 2 is 18. And if n is 4, n squared is 16 times 2 is 32. And I'm going to subtract that and see what I've got left. So 11 take away 2 is 9. 26 take away 8 is 18. 45 take away 8 is 35, 27. And finally, 68 take away 32 is 36. Now you can probably see already that this is going up in 9s. So the remainder, when I take my original sequence and I subtract 2n squared, I'm left with this sequence of numbers going up in 9s, which is basically the sequence 9n, isn't it? This is 9n. Okay, so my entire sequence then is going to be 2n squared plus 9n, what I had left over after I took 2n squared away. Okay, and that is my complete sequence. Now you can always just double check this in the end by subbing in 1, 2, 3 and 4 and just check it gives you the numbers you started with. That's probably a very good idea to do. And if you do find that, you will find that you get your 11, 26, 45, 68 back again. Question 22. Solve x over x plus 4 plus 7 over x minus 2 is equal to 1. You must show your working. Okay, so we've got some algebraic fractions here, and it forms an equation that we then need to solve. Now, don't panic when you get algebraic fractions. They are just the same as ordinary fractions. If you can add ordinary fractions together, you should know how to do or work with algebraic fractions as well. If I ask you to add a half plus, I don't know, a third, what you would need to do is you need to find a common denominator, wouldn't you? So you would put that all over one fraction. Now the common denominator of 2 and 3 is 6, which is basically 2 times 3, isn't it? Okay, and we're going to do something similar here. We're going to find the common denominator of these two expressions and put it all over one denominator. So if I combine x plus 4 with x plus x minus 2, I'm going to get that as my common denominator. Just the same way as 2 times 3 is 6, my common denominator from x plus 4 and x minus 2 is x plus 4 times x minus 2. Now what happens to the numbers on the top? I would see how many times my original denominator goes in my new denominator, and I would multiply that by, so if I multiplied that by 3, I'd have to multiply that by 3 as well, wouldn't I? And this one here, 3 goes into 6 twice, I have to do the same thing here. So basically, whatever the number is over here ends up getting multiplied up here and vice versa. Okay, so I'm going to get my x, which is my original numerator, and I'm going to multiply it by my denominator of the second fraction. And I'm going to add on my 7, which was the numerator of my original fraction, and I'm going to multiply it by the denominator of my first fraction. So we end up with something that looks like this. Okay. Now, before I do anything else, I'm going to cross multiply this up here, so we end up with a long equation rather than a fraction. So cross multiplying both sides by the denominator. So it will disappear on the left, and at the same time I'm going to multiply it out. So x times x minus 2 is going to give me x squared minus 2x, and 7 lots of x plus 4 is going to give me 7x plus 28, and that's going to be equal to x plus 4 x minus 2 then, isn't it? Okay, so then multiplying that out and collecting like terms, etc. I'm going to collect like terms on the left, so that's going to give me x squared plus 5x plus 28, just tidying up the minus 2x and the 7x. And then doing FOIL on these brackets. So I'm going to get x squared plus, can't read my writing, is that 4? Yeah, x squared plus 4x minus 2x minus 8 on the right. So just tidying that up. Got an x squared on both sides, they're going to cancel each other out. What else have I got? So I've got 5x plus 28 left here, and on this side 4x take away 2x is 2x minus 8. So taking 2x away from both sides, it's going to give me 3x. And then just finish this off. 3x plus 28 is equal to minus 8. And then taking 28 away from both sides, I'm going to get 3x is equal to, what's 8? Minus 8 take away another 28 is minus 36. Negative 36. So 3x equals negative 36. Dividing both sides by 3 is going to get x is equal to negative 12. Question 23. Prisms A and B are similar. The cross sections are shaded. We're told that prism A has a volume of 480 cubic centimeters, and we're told that prism B has a length of 30 centimeters. And we're told that the area of cross section A to the area of cross section B is in the ratio of 4 to 9, and we need to work out the area of cross section of B. Fun times. Now, when you're working with ratio and similar shapes, if we know that the scale factor of lengths is in the ratio of let's say 1 to n, then the scale factor of their areas is going to be in the ratio of 1 squared to n squared, or 1 to n squared. And the scale factor of their volumes is going to be in the ratio of 1 to n cubed, isn't it? Okay. Now, what have we been given? We've been given this one here, the area of their cross-section. So if they're in the ratio of 4 to 9, then the ratio, so if that's 4 to 9, then the ratio of their lengths is going to be the square root of that. So the square root of 4 is 2, and the square root of 9 is 3. So that means their lengths are going to be in the ratio of 2 to 3. And their volumes then are going to be the cube of 2 and 3. So they're going to be in the ratio of 8 to 27. Okay, once we know that, it should be fairly straightforward to work out the rest. Right, because we know that this one is 30 centimeters and it's a length, then its ratio is 2 to 3 with this one here. In other words, this length is going to be 30 divided by 3 times by 2, isn't it? It's going to be 20. So 2 to 3, 20 to 30. So that has a length of 20 centimeters. We know that the volume of this shape is 480 centimeters cubed. So then the area of this cross section is going to be 480 divided by 20. So this area here is going to be 480 divided by 20, which is 24 centimeters squared. Does that make sense? Area of a cross section is its, sorry, the volume of a prism is the area of the cross section times its length. We know the length is 20. We know the volume is 480. So 480 divided by 20 will give me the area of the cross section, 24. So we know that that has a cross section of 24 centimeters squared. Now we want to know this one here. We want to know the cross section of that one. And we know the ratio then between those two is in the ratio of 4 to 9. So if we take our 24 centimeters, which is the area of the smaller cross section, and we scale it up with the ratio of 4 to 9, so what's that? We divide it by 4 and we times it by 9, we should get the area of the bigger cross section. 4 into 24 goes 6. 6 times 9 is 54 centimeters squared. So that's the area of larger, or it's a cross section of B, isn't it? Area of B cross section. We've worked that out to be 54 centimeters. So that's our answer, 54. Question 24. Show that 2 root 6 divided by root 5 minus root 3 divided by root 10 can be written in the form of c root d over 10, where c and d are integers. Okay, so what can we do here then? Now, a bit similar to the problem with algebraic fractions, here we've got surd fractions. We're going to have to come up with a common denominator to work out what's going on here. So if we made the common denominator, well, let's try and rationalize our denominators first and see what we've got. So I'm going to get rid of the surd parts of each of these fractions and then reassess, I think. Let's get rid of the surd. So 2 root 6 over root 5. I can rationalize these denominators by multiplying top and bottom by root 5. And I'm going to be subtracting root 3 over root 10. And again, I can get rid of the irrational part by multiplying top and bottom by root 10. Okay, so let's do that and see what we get. So obviously on the bottom, root 5 times root 5 is 5. That's why we're doing it. And on the top, I'm going to have 2 root 6 times root 5, which is the same thing as 2 root 30. and I'm subtracting. So root 10 times root 10 gives me 10 as my denominator. And on the top, I'm going to have root 3 times root 10 again, which is root 30. Okay, so now I've got 2 root 30 over 5 minus 30 over 10, root 30 over 10. Okay, so if I double up that first one, if I times top and bottom by 2, it should give me a denominator of tenths then, shouldn't it? So that's going to give me 4 root 30 over 10 minus root 30 over 10. Okay, so now I can put them over a common denominator of 10 then, can't I? Because they've both got a denominator of 10. And then to do that, I just need to subtract the numerators. So 4 root 30 minus root 30 over 10. So what's 4 root 30 minus root 30? Well, you can treat these a little bit like you would with x's. If I had 4x take away x, I would get 3x. So it's the same thing here, isn't it? If I've got 4 root 30 take away root 30, it's going to give me 3 root 30 over 10. Okay? So I've done it then, haven't I? So 3 root 30 over 10. That seems to work. C and D are both whole numbers. And it's a fraction over 10. Question 25. A quadratic curve intersects the axes at minus 3, 0, 3, 0, and 0, 18. Work out the equation of the curve. So we've been given a quick sketch of this curve. I can see the roots here. This is the y-intercept up here, isn't it? Okay, and I want its equation. Now, parabolas that are this way round, with the roots here and here, like a and b, that has an equation in the form x minus a, x minus b, wouldn't it? Something like that. So in this case, I've got minus 3 and 3 as my roots. So they're going to be something not unlike that, x minus 3, x plus 3, for my two roots here. Okay, but that gives me a kind of a smiley parabola. What we want is a frowny parabola, one that's this way up. Okay, and if I do it that way up, I need to take one of these brackets and switch it around. It makes sense to do that first one, I think. 3 minus x, x plus 3. That will give you a frowny parabola, because when you multiply that one out, I'm going to get a minus x squared term. Okay, so if I did have that graph though, this point up here is going to be 9 though, and not 18, because 3 times 3 is 9. Okay, now I want to keep the roots the same, but I want to stretch this graph, so instead it goes through 18 and not 9. So if you know your graph transformations, you should know that you can do that by multiplying an equation by 2. Okay, so that is going to be the final form of my equation then. It's going to be y is equal to 2 lots of 3 minus x, x plus 3. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. Question 26. The area of this triangle is 25 root 3 centimeters squared. Work out the value of w. Give your answer in the form of a root b, where a and b are integers greater than 1. Okay. So the area of this triangle is 25 root 3. So we know that the middle of this is 25 root 3 centimeters squared. Okay. Now, we're going to be using trigonometry here, and we're going to be using it twice. Firstly, so I can find my value of x, and then once I've found x I can go on to find the value of w using the cosine rule. But we're going to find the value of x first using the equation for the area of a triangle that is trigonometric. So what is the trigonometric area of a triangle? We know that the area of a triangle is equal to half AB sine C, where A and B are the two sides and C is the included angle. So here we know what the area is. We know it's 25 root 3. So let's sub in everything we know. That's half. A is 20. B is my x value that I'm trying to find. And sine C is the sine of 60 degrees. Okay. So what do we know from here? Let's just try and multiply it out and simplify it down. So 25 root 3 is equal to, what have we got on the top? We've got 20 times x times the sine of 60 divided by 2. Okay, let's just get rid of the divided by 2 first. Let's make that 10. So I've got 10x times the sine of 60. So that's 10x. What is the sine of 60? Now, that's again, it's one of our exact values that we talked about earlier when we were looking at one of the earlier questions. And if you remember that table of values that I pulled up earlier, you should remember that you need to know that the sine of 60 is root 3 over 2. Okay, so we're getting there, aren't we? So now what can I do? I've got root 3 on both sides. I've got a root 3 and I can cancel it with that root 3 there. That should make life a lot easier. I can divide the 2 into the 10 and make 5. So now I've got 25 is equal to, well, it's equal to 5x. And then divide both sides by 5. I'm going to get x is equal to 5. Okay, so that's promising. So now coming back to my diagram, I know that that x is equal to 5. So now I've got two sides and an included angle, and I want to find the third side. This looks like a job for the cosine rule. Okay, so the cosine rule. Using cosine rule, what's the cosine rule say? It says c squared is equal to a squared plus b squared minus 2ab cos c. Okay, so it's a bit like the Pythagoras theorem with that extra little bit on the end. So here, c is my w, isn't it? So w squared is my two sides that I know, which I now know are 5 and 20. So it's going to be 20 squared plus 5 squared minus 2 lots of 20 lots of 5 times the cos of the angle, which is 60. Okay, so let's see that through. 20 squared is 400. 5 squared is 25. Minus 2 times 20 times 5. 2 5s are 10. 10 20s are 200. So that's 200 lots of cos of 60. Now again, from our table, we should know that the cos of 60 is a nice easy one. It's a half. So a half of 200 then is 100, isn't it? So I've got 400 plus 25, 425. Take away 100. That gives me 325. So my w then is going to be the root of 325. Is that what they wanted? Give your answer in the form a root b, where a and b are integers. Okay, so basically now we've got 325, and what we need to do then is simplify that surd down. So we're going to be looking for factors of 325 that are also square numbers. I think 25 is screaming at me at the moment. How many 25s in 325? Well, there are 4 25s in 100, so 300 has got 12, plus another 25 is 13, isn't it? So that is 25 times 13, and the square root of 25 is 5, so that's just 5 root 13. So w is 5 root 13. That's a fun question. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 27. Here is a sketch of y is equal to the cos of x for values of x between 0 and 360 degrees. And we've got the very familiar cosine curve there, starting at 1 and going down to 0 when alpha or x is 90. We're told that alpha is an acute angle, and we know that the cos of alpha is equal to k. Okay, so circle the value of cos of 180 minus alpha. So having a look at the properties of the graph, so if we're saying alpha is this distance from here to here, then 180 minus alpha is going to put it somewhere around here then, isn't it? Okay, it's kind of like the mirror image. If that was the mirror line there, then alpha is going to be here. And then reading down to the line and across, you should find that there's k. Well, it's going to be minus k, isn't it, down there? So up there it's k, and down here it's minus k. Okay, so it's going to be that one there. And circle the value of 360 degrees plus alpha. Okay, so basically it's just repeating itself, isn't it? This curve is going to come back down like this. If I move alpha on from here and read up to the curve and back, it's going to be in the exact same place. It's going to be at k again. So it's going to be k. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.